We're on. Shh. Act normal. Alright, rules for exponents. The first one, I just said it to you guys. I don't really care about the name of this rule, but the name of this rule happens to be product of powers. Yes, I'm going on tape saying I wrote it down wrong 3 times before we started, but here's this rule. That a to the power of m times a to the power of n equals a to the power of a m plus n, which seems a little bit weird, but it's not. What's true about this a here, and what has to be true about this a here and this a here? It's really important. Yep. They have to, right, they have to be the same number. So look how that might work. So we have 5 to the third power. Let that be that. And we have maybe, I don't know, 5 to the second power, and let that be that. And let this multiplication sign right here be this multiplication sign right here. Alright? And see if that doesn't work. So let's just expand this out a little bit and look at this. We have 5 to the third power is 5 times 5 times 5, isn't it? So that's this one. 5 times 5 times 5. This multiplication sign, again, is this multiplication sign. Now we take this 5 squared and expand it, and that's 5 times 5. Now what I'm wondering is, isn't this true that we have, it says here we have a to the m plus n. Well, a in this case is 5, isn't it? And it's 3 because we have, right? Because we have 3 factors of 5 here. Plus 2 because we have 2 factors of 5 here. And here's the counting part. Ready? Factors of 5, how many?
1, 2, 3, 4, 5.
And 3 plus 2?
5.
It is true, isn't it? Because it looks like, if you look at the rule for a second, the rule looks pretty, I don't know, pretty difficult. But the truth of it is, it's pretty straightforward, isn't it? A similar rule is the next rule. And that rule, just so you know, is called, look in the book, is power of a power. I'm not even going to write it down, but this is power of a power. And in this case, we take a to the m to the power of n is equal to a to the m times, times n. Is that all right? This also looks pretty good, but if you think about it, look, here we have like 5 squared here, don't we? The factor here is 5, isn't it? And we have 2 of those factors, so it's 5 times 5. I'm not sure it describes this rule perfectly yet, but if you extend it just a little bit more, maybe take another example and use, I don't know, 3, I guess. 3 to the power of 2 raised to the third power. What's the factor here? If you look right here, the factor here is 5 to the first power, isn't it? This was 5 to the first power, and here they are. We have 1 factor of 5 to the first power and 2 factors of 5 to the first power. And yeah, in this case, what's the factor?
3
It's 3 squared. And how many factors of 3 squared do we have? 3. So we have 3 squared times 3 squared times 3 squared. We could use rule number 1 if we expanded it out this way and just add them, couldn't we? But multiplication is repetitive addition, isn't it? So we can just multiply. 2 times 3 is 6, right? Or, if you wanted to, 2 plus 2 plus 2 is also 6. Is that rule okay? So far, so good?
Yes.
Okay. Third rule. Third rule. It's just the extension of this. It says a times b to the power of m equals what? What is a times b to the power of m? This asks the question, doesn't it? It asks the question, are exponents distributable over multiplication? Are they, Cecilia? They are. And therefore the answer will be what? A to the m times b to the m. a little bit of proof. Okay, let's take 6 squared. Is that all right? 6 squared is what? Really? Seriously? 36. Thanks. And all I'm going to do is I'm going to take factors of 6 and see what happens. So I'm going to take this problem right here, and I'm going to just factor it out a little bit. I'm going to say, okay, you know what? This is 2 times 3. 2 times 3 is this 6. Is that all right? And then it says that we're going to square it, so that's the square. What I'm trying to figure out is, can I do this? Can I turn this into 2 squared times 3 squared? So we'll end up with 2 times 3. When we distribute this 2 right here, goes to here, so we'll have 2 squared, 3 squared. 2 squared is 4. Wow, that's not a 4 though. Is 4. 3 squared is 9. And 4 times 9 is 36. So this rule looks kind of weird, but it's not, is it? So, but as an example, what would this look like? What if I took 2xy, how about this? Y squared to the 3rd power. If I use this rule in this problem, what happens here? Quint?
Becomes 2 to the 3rd power times x to the 3rd power times y to the 6th power.
Nicely done. Yeah, exactly what happens. Right, this is to the 1st power, and 3 times 1 is 3, isn't it? So you're right, we have 2 to the 3rd, x to the 3rd, y to the 6th power. Of course, this can be simplified, can't it? 2 to the 3rd is something we can work out pretty easily, and 2 to the 3rd power is 8, isn't it? And you would be expected to do that. So far, so good? Okay. Negative exponents? Negative exponents? So what happens with negative exponents? A lot of people think negative exponents create what? Not what do they create, what do a lot of people think that they create? Yep. People think that they make negative numbers. Do negative exponents make negative numbers, yes or no? No. What do they make? Nice. Perfect. Yes? They make fractions. So a to the negative m equals what? David? A 1 over a to the... I know you know what you were talking about, but you said it weird, but yeah, right? And why is this true? Look, it really is true. Let's take a really easy example. This is just arithmetic. And we have, let's say we take, let's do this backwards if you don't mind. Let's start here. Is that all right? And prove it turns it into a negative fraction, okay? What if we have 5 over 25? What's 5 over 25? It is 1/5, isn't it? 1/5. But we have another rule of exponents that says, oops, what if I trade this in like this and I take this as 5 squared? This is still 5 over 25, isn't it? Yes? But now, wouldn't we do 5 to the what? Brandon? Do 5 to the 1 minus 2 power, which is equal to 5 to the negative 1st power. But we already know that it has to come up to this answer, doesn't it? Right? All good? Okay. So, negative powers. How about 0 exponents? What happens with 0 exponents? What is a, whoops, what is a to the 0 power? Yep. A, say that again? That's right, a cannot equal 0. The reason this freaks everybody out too, the reason this is true is this. Look, let's take 2 squared over 2 squared, right? Which is equal to 4 over 4, isn't it? Which is equal to what? Which is equal to 1. But if we use this rule of exponents here for division, we'd have 2 to the 2 minus 2, wouldn't we? Isn't that right? And 2 to the 2 minus 2. 2 minus 2 is 2 to the 0. But we already know recursively the answer has to be 1, doesn't it? Is that okay? I think these were actually done backwards. How about this? A to the m over a to the n. Well, we know if we multiply fractions, we add their exponents. So if we divide them, what do we do? Would you? We subtract, so we'll have a to the m minus n, won't we? Yep. Yeah. It's really Yeah, it's really important and perfectly said. This a and this a must be the same number. That's why they're calling them a. Otherwise, what you'd usually do in this notation, you'd write a over b or something, right? But that's a really, really good point. And again, that would look like this. Take some answer that we know. 2 squared over 2 to the third. Actually, let's do this backwards if you don't mind. Let's do 2 to the third over 2 squared. What's 2 to the third power? Yeah. It's 8. And what's 2 squared? Yes, 4. And 8 over 4 is 2. So we know the answer has to be 2, don't we? We know the answer has to be. So let's try this rule and see if it will work. We'd get same factors, 2 and 2 here. So we have 2 to the 3 minus 2. And 2 to the 3 minus 2 is 2 to the first. And 2 to the first is just 2, isn't it? That's all. One more rule. One more rule. One more rule. That rule is this. Tell me how this is going to work out. A over b to the power of n. And this is an example here where these numbers here don't have to be the same, do they? And what are we allowed to do with this n? We're allowed to distribute because exponents are distributable over multiplication, and therefore they're automatically distributable over division. They're the same thing, aren't they? So this would equal a to the what? A to the n over, wow, I almost screwed that up, over b to the n power. Right?